So let's sketch these points and try to check if we really understand how we can pinpoint these on the XYZ space. Here you go. A point is 2, 4, 6. So what did we say? We will go 2 units on the x-axis. So I'm here at this point 2. Here. You can see that, right? At this point 2. And then we will go 4 units parallel to the y-axis. So I am going 4 units parallel to the y-axis. 1, 2, 3, 4. Here we go. I am here. Check it on the xy plane. And then we will go 6 units parallel to the z-axis. So I'm going up. 1, 2, 3, 4, 5, 6. Here you go. This point, the last one that you stand, is the point that you are looking for. 2, 4, 6. Okay? And similarly, let's look at it. 4, 0, minus 1. So we are going 4 units on the x-axis. 1, 2, 3, 4. I'm here. We are going 0 units on the y-axis. So I'm staying. I'm not moving anywhere. And then negative 1 units parallel to the z-axis. This is z-axis. Since it is negative 1, I'm going down. Here you go. This is negative 1. And this place is the place for the point 4, 0, minus 1 on the given space. And similarly, if we look at the 0, 5, 2, we are at the origin. We are not moving anywhere on the x-axis because we have 0 as a value. Then I will move 5 units on the y-axis and then 2 units parallel to the z-axis. This is 2. So you have the C point, 0, 5, 2. Exactly, this is how you can show the points on the XYZ plane. And let's look at another example. What surface is in R cube represented by the equation z equals 0? So if z equals 0, what do you have? This is the z-axis. Think about that. And you are looking for all points other than z, which z should be 0. So this will be the xy plane that is passing through z equals 0 at the origin, right? So this is the xy plane. Once you look at it, y equals 0, then you are imagining the xz plane because y is 0 and what you have is all the points that is passing through the x and z. And maybe in this one you can see those much more easily. Here you go. This is what we said. This is the xy plane, z equals 0, the equation for the xy plane. The equation for the xz plane, you can think that equals y equals 0. Here you go. And for x equals 0, the same idea. If x equals 0, y and z is gonna form a plane of yz. And x equals y, think about that. This is y equals 5. Okay, let's check it. Y equals 5 first. So it will be the plane that is parallel to the xz plane. But instead of going through the origin, which is y equals 0, it will be passing through y equals 5. Right? And what is that? Y equals 5. It's the line. So if it is the line, this will be just on the xy plane. This is a line that is passing through y equals 5. And the last one is x equals y plane. X equals y plane. It's gonna form all the z, but when x, y, and z is positive, it will be the upper region of the space. So you have this plane. Okay, try to imagine those planes. So in this three-dimensional geometry, you will need to imagine all of those, and you know that we will be talking about triple integrals, double integrals. So you need your imagination, you need to trust your imagination. Let's start from the beginning, okay?